Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 3.2. It's just more quadratic equations and another way of solving it. When you cannot find the factors because numbers are large, or sometimes it's not factorable, you can use the quadratic formula. And the quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. You should have that memorized. To use it, first we find our a, which is 3, our b, which is 5, and our c, which is a negative 8. What's nice is this one always works. So when you can't find factors or you're not sure, rather than wasting time, this always works. And if you get a negative under the radical, then there's just no solution. So plugging it in, negative b, negative 5 plus or minus the square root, 5 squared minus 4 times a times b all over 2a. So 2a was 3. This was 4 times ac, so 3 and negative 8. So negative 5 plus or minus all over 6. And we want to plug this part into our calculator. 25 minus 4 times 3 times a negative 8. 121. And that's a perfect square, which is nice. So we have negative 5 plus or minus 11 over 6. Because the square root of 121 is 11. Now to find those values, then you take the positive, negative 5 plus 11 over 6, and negative 5 minus 11 over 6. So when we add these, 6 over 6 is 1, and 16 over 6 reduces to a negative, divide by 2, 8/3. Look at the next one. A is 2, B is 1, and C is a negative 6. One thing you want to remember, you don't take the variable with it. It's only the numbers that are in front. So negative b plus or minus the square root b squared minus 4 times a and c all over 2 times a. 1 plus or minus the square root all over 4, and then combine under your radical. 1 minus 4 times 2 times a negative 6 is 49. So we have 1 plus or minus square root of 49 is 7 over 4. 1 plus 7 over 4 and 1 minus 7 over 4. So 8 over 4 is 2, and negative 6 over 4 is a negative 3/2. So that's how you would use the quadratic formula. Now both of these would have factored, but it's not as easy to factor when there's a number in front. So quadratic formula is a good one. And then we'll look at a couple story problems. Number 67 says the total revenue function for French door refrigerators is given by R equals $550x, and the total cost function for the same product is given by C equals 10,000 plus 30x plus x squared, where C is measured in dollars. For both functions, the input x is the number of refrigerators produced and sold. Form the profit function for the refrigerators from the two functions. Okay, so we have R of x equals 550x, and our cost is 10,000 plus 30x plus x squared. Measured in dollars, so they're both dollars. And x is the number of refrigerators produced and sold. So it's the number of fridges. Profit is revenue minus cost. So our profit is our revenue, which should be 550x, minus the cost. Now remember, you have to subtract the whole cost. Make sure I wrote that right. Yeah, it's a plus. So we have a negative x squared distributing this. We have negative 30, and the 550 gives us a positive 520x minus 10,000. So distributing this negative made this one negative. And then this became a negative 30x with the 50x was 520 and a negative 10,000. So that's our profit function. Part B said, what is the profit when 18 refrigerators are produced and sold? To find 18, we would just plug in 18. Let's just plug it in here. You want to be careful, only the 18 is squared, not the negative. When you plug that in, a negative 964. So we haven't made a profit yet. We are still in the hole, $964. C says, what's the profit for 32 fridges? So if we produce and sell 32, so 32. $5,616. So if we produce and sell 32 refrigerators, we'll make $5,616. D is the break-even point. Break-even is important because that's where you start making money. And we know it's somewhere between here and here because we were losing here, we're making it here. Excuse me. So it's somewhere between 18 and 32. Well, your break-even is either when your revenue equals your cost, so you could set those equal to each other, or you can set your profit equal to 0. So if we take the profit function we found, negative x squared plus 520x minus 10,000 and set equal to 0. Now 10,000, two numbers that multiply to give us the 520, plus we have a negative in front. We'd have to get rid of that too. Quadratic formula would be a lot easier for this because the number's so large. A is negative 1, B is 520, and C is a negative 10,000. So we have negative B plus or minus the square root, 520 squared, minus 4 times A times C, all over 2 times A. So 520 squared minus 4 times a negative 1 times a negative 10,000. You get this? So let's see if it's a perfect square. Of course it is, so it's 480. The square root of this is 480. So we have negative 520 plus 480 over a negative 2, and a negative 520 minus 480 over 2. We get 20 and oh, this is a negative 2. 520 and 480 is 1,000 divided by 2 is 500. We have two answers. Well, what happens is the cost was a parabola and the revenue was a line. So you have this revenue and cost. There's two parts where they not break even, but where they're equal to each other. Well, we want the minimum one because that's where we start making money. This one is where you start losing because the cost is above the revenue. So this line is your revenue, and it's going like this. This is your profit in here. This one is where you start making money because now the revenue here is above the cost. And then this is where you start losing money. So you want the smaller value. So we start making money, or we break even, when 20 refrigerators are sold. How many refrigerators must be sold to break even? Yeah. I don't think they'll ask for both values. Look at the answers real bit. Click on My Labs 8. D. They do have two answers. I think they do want both answers because both of them are a break even, but usually you want the minimum break even because that's where you start making money. but on my math lab, they are looking for both answers. So if they say minimum break even on anything that comes up later, then they only want the smaller one. But for right now, they want both values. I'll try one more. Supply and demand. Number 73. Suppose that the demand for artificial Christmas trees is given by this function. So this one's demand. And supply, this one. Where P is the price of a tree in dollars and Q is the quantity. Find the price that gives the market equilibrium price and the number of trees that will be sold and bought at that price. Okay, so first let me write the equations. So we have demand, and this was number 73. P equals 109.70 minus 0.10 Q, and P is price in dollars, Q number of trees. Okay, so that's our demand. Our supply, P equals 0.01 Q squared plus 5.91. We find the equilibrium point. We want to find what price we should sell them for and how many trees we will sell if we do that. Well, equilibrium point means that's where they are equal, so we want to set them equal to each other. To get it set equal to 0, we need to bring everything over to one side. So if I bring this over, it becomes a negative. And then we have the negative 0.1 Q. And then we have 109.7 minus 5.91. And we get positive 103.79. Okay. Quadratic formula. Negative B plus or minus the square root negative 0.10 squared minus 4 times A times C. Negative 0.01 and 103.79 all over 2 times A. Okay. Plugging the part under the radical in, 0.1 squared minus 4 times a negative 0.01 times 103.79. 0.1 squared minus 4 times. Just want to make sure I enter it all in right. And if we take the square root of that, you should never round until the end. So even if you keep the whole decimal in your calculator, but this one came out nice. So we have 0.10 plus 2.04 divided by a negative 0.02. And 0.1 minus 2.04 divided by the negative 0.02. Somehow I always use X's, but it is Q for quantity. Now when we calculate these, this one we get a negative 107. And on this one, we get, I want to make sure I calculate it right, 0.1 minus 2.04 divided by 0.1 minus 2.04. Okay, I thought I did something wrong. It's 97. Now we're talking about a quantity, so a negative amount doesn't make sense. 97 Christmas trees would be our equilibrium quantity. To find the price, and they'll sell for, we need to find that. Now to find that, you take either one of these and plug it in. I'm going to use the first one, but if you plug it into both, it's a good way to check your answers because they should come out the same. But P equals 109.7 minus 0.10 times the 97. So I just took that from this one. But you could have used either one. 109.7 minus 0.10 times 97 equals 100. So we're going to sell the Christmas trees for $100 each, and that means we will sell 97 of them. And that's everything in 3.2.